Break-even analysis, again, is the calculation of how many units we need to be selling in order to make zero profit. We need to calculate the break-even quantity or break-even level of output where profits are equal to zero. And this is calculated as the division of the fixed costs divided by the contribution per unit, where, remember, the contribution per unit is equal to price minus average variable costs. Therefore, we can already see from here that for as long as fixed costs are greater than zero, necessarily the break-even quantity will be greater than zero. And we're going to now calculate an example. Say that for our Planet Earth company in Kent, we are told that they got salaries equal to £2,000 and they have to be paying an interest on a loan of £1,000. In total, this means that the fixed costs are equal to £3,000. Again, those are costs that do not change with the level of output. We're also told that the company has the following variable costs: £1 of water per unit of output and £2 in seeds per unit of output. That means that the average variable cost is equal to £3. In addition, we're told that the company is selling 2,000 tomatoes and it's selling each tomato at £5. Now we're going to be calculating the break-even quantity. We start by calculating the contribution per unit, which is equal to price minus average variable cost. In our case, the price is equal to £5 and the average variable cost is equal to £3, which means that the contribution per unit is equal to £2. Then we can calculate the break-even quantity, which is equal to the total fixed cost divided by the contribution per unit. Total fixed cost in our case is £3,000 and the contribution per unit is equal to £2, which means that we need to be selling 1,500 units. Now be careful in here, the break-even quantity is expressed in units. It's the number of units that we need to be selling. It's not a monetary unit. We can also calculate what the margin of safety is. The margin of safety is an expression of how many units we are selling at the moment compared to how many units will make our profit be equal to zero. In other words, how many units can we stop producing before we start making a loss? In our case, since the company was producing 2,000 tomatoes and the break-even quantity is equal to 1,500 tomatoes, our margin of safety is equal to 500 units. We can represent all of these calculations in a diagram, and in fact, you will be required to do so in the exam. We're going to follow the same example to represent this diagrammatically. First thing, in the exams, you will be given graph paper. However, you won't be provided with the scale. So first thing you need to remember is what are the axes. The y-axis is always cost and revenues, and the x-axis is the output and sales. The cost and revenues expressed in a monetary unit. Could be euros, could be in our case pounds, or whatever the exercise is about. Make sure that you read the information carefully and adapt the axis accordingly by expressing it in the correct monetary unit. Second, we have already calculated the break-even quantity, and this is very important for the scale of the x-axis of the output and sales. In our case, we calculated that the break-even quantity was equal to 1,500 units. So it makes sense to write 1,500 in here and then leave room on either side in order to produce our following analysis. If you had written at the very end of the paper, at the end of the page, 1,500, that will make it very difficult to then produce further analysis, for example, on the margin of safety. If you write a scale that is too small, say 1,500 in here, everything will be end up concentrating here. So I recommend to write the break-even quantity around the middle of your diagram and make sure that the units are legible. Next, since we already have the break-even quantity, we can then calculate what is the break-even point. And this is very useful to do the same exercise, but this time for the y-axis, the costs and revenues. Since we know what is the break-even quantity, we can very easily calculate what is the total revenue at this point. The total revenue is always equal to price times quantity. Since we know the price and the quantity, we can know the revenue, and in this case the revenue will be equal to the 5 of the price times the number of units in the break-even quantity, 1,500, and that's equal to 7,500. Again, I recommend to write down this level of total revenue somewhere in the middle of this diagram to leave enough room on either side to conduct our following analysis. With this, we already have the break-even point. You will only be required to draw linear functions. And with linear functions, you only need 2 points in order to draw your diagrams. This means that you already have for all your curves one of the 2 points that you need in order to draw your diagrams. So, first, you should be drawing, or my students usually find easiest to draw the total fixed cost. Because total fixed costs do not change with the level of output, they're always constant. In our case, we estimated or we calculated our fixed cost as being equal to 3,000, and since they do not change with the level of output, that means that they're always constant. Therefore, you can draw the total fixed cost as a straight curve, always. You can then draw the total revenue curve. The total revenue curve is easy to draw because total revenue is equal to price times quantity. That means that when the quantity is equal to 0, that means that the total revenue is equal to 0. Price times quantity equal to 0. That means that when the quantity is equal to 0, the total revenue is going to be equal to 0. The total revenue curve always starts at the axis intersection, at 0. And since we already have another point for this curve, which is the break-even point, all you have to do to draw the total revenue curve is join these 2 points. Again, the total revenue curve always starts at the intersection of both axes. Finally, you can draw the total cost curve. For this curve, there's also a hint. When the variable cost, since the variable costs depend on the level of output, that means that in order to calculate the total variable cost, we need to multiply the average variable cost times quantity. Now, similarly with the total revenue, when the quantity is equal to 0, that means that the total variable cost will be equal to 0, because average variable cost times quantity will be equal to 0. However, total cost is equal to total fixed cost plus total variable cost. That means that when the output is 0 and total variable cost is 0, what's left is the total fixed costs, in our case 3,000. The total cost curve always starts at the intersection of the total fixed cost with the y-axis, because that's the point where total variable cost is equal to 0. And the same thing as the total revenue, since we know the total cost equals total revenue at the break-even point, that's the second point where our curve will pass through, and we only have to join these 2 points, the point of the crossing of the y-axis plus this break-even point, and it's a straight line, and that's our total cost curve. We should also be representing in this diagram the margin of safety, which is the difference between how much we're producing at the moment, 2000, minus how much we should be producing to make zero profit, which is the break-even quantity, 1500. And this is represented as the margin of safety, which in our case is equal to 500. And this is the basic diagram of the break-even analysis and how to build it. Now we're going to be doing analysis by changing some of the variables, which is something that you're also required to do. We're going to start with a change in fixed cost. Now suppose that you're told that interests are increasing and therefore the total fixed cost for our company has increased to £4,000. We start with the same diagram, is the one that we draw, and we need to proceed as follows. One, we plot the new total fixed cost curve. Since we need to follow only the same logic as before, and we just need to have a new total fixed curve that is higher because now our fixed costs are equal to 4,000. But the gradient never changes because by definition, total fixed costs do not change with the level of output. Second, we need to plot our new total cost curve. Since the total fixed costs have increased, that means that the total cost curve will also be shifting upwards in this case. How much upwards? Well, it will depend again on the intersection of the total fixed cost curve with the y-axis. So it's a parallel shift of our previous total cost curve. We can also know that from calculating the new break-even point, because we can calculate that in fact the break-even quantity now should be equal to the total fixed cost, £4,000, divided by the contribution per unit, which hasn't changed because neither the price nor the average variable cost has changed, and that's equal to 2,000 units. So we know that for our new curve, the break-even quantity is going to be equal to 2,000 units. We can calculate then the total revenue at that point. The price was equal to 5, and now we have 2,000 units as the break-even quantity. Therefore, our total revenue is going to be equal to £10,000 in our case. And if we join these two, then we get the new break-even point, which is where total revenue is crossing the new total cost curve. When total fixed costs rise, that means that we need to be selling more units in order to make zero profit, which makes sense because we still have the same contribution per unit, but we need to distribute our profit per unit among more fixed costs. When fixed costs fall, that means that we need to be selling less units in order to make a zero profit. Now we're going to be seeing the example for variable costs. Suppose that now we're told that the price of water has increased and therefore the average variable cost of our company have increased to £3.5 per unit. Now notice that in this case now the contribution per unit has changed. So that's the first thing that you need to calculate. The new contribution per unit is going to be equal to 5 minus 3.5 because average variable cost has increased and therefore the CPU has decreased to 1.5. With this, we can calculate now the new break-even quantity. £3,000 divided by 1.5 pounds equals to 2,000 units of output that has to be sold in order to make zero profit. At 2,000 units, we will be making £10,000 in revenue, and that's what we need to represent. With these two units in mind, we already have our y-axis and x-axis units. We can now find the break-even point. That's where our total revenue and total cost are going to be equal. Since total fixed cost is not changing, the only thing that we need to shift in our case or change in our case is the total cost curve. Again, total fixed cost is not changing, which means that the total cost curve still has to intersect the y-axis where total fixed cost intersects the y-axis, because that's the point where variable costs are equal to 0. Which means that the only way to draw the new total cost curve as crossing this point in here where total fixed cost is equal to 3,000 and the new break-even point is by changing the gradient. And that's our new total cost curve. In general, when variable costs increase, that means that the gradient for the total cost curve will increase. And when the variable costs decrease, that means that the gradient of the total cost curve will decrease. And that's all. There's no other curve changing in this case. We're going to conclude by looking at changes in a price. Now, suppose that we're told that the price of each tomato has increased by £1, which means that now we're selling them for £6. In our case, the first thing that we need to calculate now is the contribution per unit, because now this is changing as well. And that means that since price has increased, our contribution per unit has increased. This makes sense. What we're saying is that since we're selling each tomato at a greater price, there's more money left from selling each tomato to pay for the fixed costs. Second, we calculate the new break-even quantity. In our case, £3,000 divided by the new CPU, that equals to 1,000 units. And then we plot it. We have the new break-even quantity that equals to 1,000 units. With this 1,000 units, we can now calculate the total revenue. The total revenue for 1,000 units is going to be equal to 1,000 times the new price, which is equal to 6, which is equal to £6,000. And that is what we can plot now in the y-axis. And since we already have the two coordinates, we can finally plot the new break-even point. And that gives us the second coordinate for all our curves, total revenue and total cost curves. We know that total revenue and total cost need to be equal at this point in here. Since we are not changing any costs, we can easily see now that all we have to change is the total revenue curve. And how do we do this? Well, we know that it starts at 0 because total revenue always starts at 0, and it has to cross this point in here, the break-even point, because that's where it's equal to the total cost curve. And that's it. In general, when the price increases, the gradient of the total revenue curve increases, and when the price decreases, the gradient decreases. The higher the price, the lower the smaller the number of units that we need to be selling in order to make zero profit, and vice versa. And with this, we conclude on all the potential diagrammatic analysis that you can do. In the exam, however, you might be asked to do other several calculations. The break-even quantity is the level of output where our profits are equal to 0, where total revenue is equal to total cost. However, this same analysis can allow us to calculate how many units we need to be selling in order to reach a certain level of profit. In other words, we're not only interested in where our profit is equal to 0, the analysis is also useful to calculate where can we achieve a certain level of profit. We could do it on a diagram or we can do it with calculations. So let's start, for example, with the target output. Suppose that our firm wants to aim for a certain level of profit by keeping the same price, and our costs don't change and our price don't change. The only way that we can reach this profit then is by changing our quantity sold. This is our data from before, And what this means is that our current profit is equal to £1,000. That's £5 per unit sold times how many units are sold. That's our total revenue, equal to £10,000, minus the total costs. And the total costs are equal to £3,000 in fixed costs, plus the £3 in average variable cost times the number of units sold, 2,000. And that's equal to £1,000. Suppose that our company wants to aim for a profit of £2,000. Then we need to calculate how many units it should be selling in order to reach those £2,000 in profit. In practice, this is quite easy because all we need to add then is £2,000 to our fixed costs. Essentially, we need to be reaching a new break-even quantity, but instead of having zero profits in there, we're going to be having £2,000 in profit. And so we just need to substitute in our formula fixed costs equal to £3,000 plus our target profit divided by the contribution per unit, and that gives us that the company should be selling 2,500 tomatoes in order to reach that target profit. Some companies, instead of aiming for a certain level of profit, they may be aiming for a certain level of output, which means that output is our known variable in this case, and we need to then calculate what is the profit that we will be having at that level of output. And we can calculate this by using the same formula and clearing it up. This was our previous formula, and in here we have the target profit level of output, but now this is a known variable. What we don't know is this now, this target profit, but we can clear this up and we can reach this last formula, which is that the target profit of output times C contribution per unit minus fixed costs will be equal to the target profit. Suppose that our firm wants to aim to produce 1,800 tomatoes. What will be, in our case, the target profit resulting from this level of output? All we have to do is substitute the units. 1,800 units sold times the contribution per unit, which is equal to £2, minus the fixed cost, which were £3,000, and that's equal to £600 in profit. What this means, again, is that if the company is aiming to produce 1,800 units of tomatoes, it will be making £600 in profit. Other times, the companies might want to reach a certain level of profit with a certain level of units sold. And in that case, the variable that they have to decide is what is the price at which they need to be selling their units in order to reach that target level of profit. Say that in our example, our company wants to sell 1,500 tomatoes and have a profit of £500. What should be the price at this point? Well, what we don't know now is the contribution per unit. That is an unknown variable because we don't know the price. That's what we can decide. But we can still use the same formula to clear this up. And we start by inputting all the figures that we know. We know that we are producing 1,500 units of tomatoes. The £3,000 is our fixed cost, and the £500 in here is our target profit. We also know our average variable cost, which is equal to £2. If we pass the formula to the other side and clear this up step by step, we reach the solution that the price should be equal to 4.33. What this means is that in order to reach a profit of £500 by selling 1,500 tomatoes, the company should be setting a price of 4.33. You should get familiarized with this formula in here and how to be able to clear it and be able to play with those formulas. And those are all the calculations and diagrammatic analysis that you may be asked to conduct in the exam.